Thank you for the opportunity to talk today. I'm a PhD student at Rhodes, and I'm going to be talking a little bit about my project. I'm in the very early stages, so it's more of a proposal, really. My work is looking at Egeria densa. It's an invasive plant in South Africa, but with the overall aim of exploring mechanisms of submerged invasions. So what is Egeria densa? Well, it's also known as Brazilian waterweed. Its native range is circled here in the map. You can see southeastern Brazil, northeastern Argentina, and Uruguay. It's a submerged freshwater perennial. That wasn't me. So yes, as I was saying, a submerged freshwater perennial. It's been spreading throughout South Africa via the aquarium trade. Has actually been noted in South Africa since the 1960s, but only noted as it's here, but it's not causing much of a problem. But in recent years, as with many other submerged plants, we're seeing a real spread and increase in growth. This is just a map detailing the sites that I have been on a survey with Grant Martin, where we have confirmed infestations of Egeria. We can see right down from Cape Town, here in the Eastern Cape, and up to the region we're in now, in KwaZulu-Natal. So what are my research questions? Why am I studying this plant? Well, first of all, I want to try and determine how good at invading this plant is, how much of a threat it is, and how successful will it be at invading vulnerable systems we have in South Africa. I also want to know what is driving its spread. Why are we seeing this increase now? Why hasn't this been happening 20, 30 years ago when we had this plant here? And lastly, what are the control options for this plant available to us, and which would be the most efficient methods for managing our resources? So I'm just going to go through each of those questions. So question one, how invasive is this plant in South Africa? How do we measure invasiveness? Well, before we can measure anything, we must be able to quantify it. And quantifying invasion potential requires taking a bit of a step back and thinking, what's the major concern with any invasive species across any taxa and any ecosystem? And I think really it comes down to the fact it can outcompete native species, allowing it to dominate in ecosystems and be really damaging. So if we're able to measure competitive fitness or ability in some way, perhaps we could use these values as an indicator of invasion potential and be able to measure our invasion potential. So I propose to do a series of competition studies between the invasive Egeria densa and the trophically analogous, sort of, I guess, native equivalent plant, Lagerosyphon major. Now, traditionally, competition studies look at perhaps growth rates or changes in biomass over time and various effects they have. But I want to look deeper into the plant. I think we have to if we're going to try and understand and also better predict which systems are most vulnerable to this plant. And as Jackie's already mentioned, we all know nutrient loading is a driver of invasion. So it seems to make perfect sense if we're going to look at competition studies between these two plants and try and decide which is the best resource competitor, that we look at the ability of these plants to take up nutrients and use that as our main focus. And we're going to do that by tracing stable isotopes, again, as Jackie was mentioning, that same methodology, through the two plants, and basically see which is the better plant, taking up nutrients, therefore growing, therefore succeeding in the ecosystem. But that's all well and good, but I want to look at the competition ability of this plant in different nutrient conditions that we've seen in the systems in South Africa. This includes when exposed to different sources of nutrients. In this case, it will be nitrogen, and it will be nitrate and ammonia. I also want to look at the competition ability that we have here when we have different concentrations of nutrients. And these will represent the different systems we have in South Africa here of heavily eutrophic systems and less heavily loaded systems. And lastly, the effects of herbivore pressure have upon these plants and their ability to uptake nutrients, which will feature importantly later with the work on biological control for this plant.